anyway. All right, so let me see. We're up to 8 participants, 10 participants. It's going up. People are joining. How are you today? Tell me a bit about you. How was your morning so far? And how are the weeks rolling? Good? By the way, you should start receiving your first graded lab report today, lab 1. So I'm going to look into it and probably start grading you. Yes, I should. So this weekend is going to be your first weekend receiving grades. Other than that, someone was asking me about the midterm. I actually don't have a fixed date, but let's open the calendar randomly to discuss issues. Today is, all right, so March 1 is gonna be next week, right? Where's March? I know for a fact that the deadline to finish lab 3 is gonna be March 6th. The deadline to finish lab 4 is gonna be March 13. So for me to grade it is gonna be around March. So probably the week of March 15. So how about we say the midterm is either March 20 or March 27? Okay, I'm gonna write it here as tentative, March 20 or March, so March 20 or March 27. May I ask you please to put your cameras on if you can for at least the first 15 minutes, please? I would really appreciate it. I have a feeling I'm talking to myself. Okay, so let's open the syllabus and see what was tentative on the syllabus and if the March 20, March 27 will fall within our tentative schedule. Because it has to go around the withdrawal period, right? That I have a feeling will be extended anyway. So, but let me try to fit within our tentative dates. So tentative date says it has to be between March 13 and March 20. What are we today? We're March 27 and we should do, okay, we're following the schedule so far. Okay, so I'm gonna pick March 20 and not, so let's erase this one. How do you feel? Because usually I want you to take part of deciding this. Do you mind? How do you feel about that? And how about we don't do it March 20? How about we do it a Friday afternoon? Friday afternoon, because I don't want us to lose a session. Because as you can see from the syllabus, which is here, we have a session on March 20. So either do the midterm after the session or do it a day before. How do you feel? So let me read your, okay, what time? Friday afternoon, okay, March 27. All right, Tiara, I totally understand March 27. Now let me see any dates. Okay, March 27. What does it say? I'm checking withdrawal. They should be written here. Okay. Deadline for early withdrawal is March 1. Deadline for withdrawal from the course is April 20. So, which means March 1, we cannot do it before March 1, it's Monday. So, which means April 20 is the second one, which means March 27 is also okay. Okay, so there's no need to change this, especially that we are only one section, so we don't need to follow other people, and we don't need to follow Beirut. The only people we should follow is Beirut, and it's okay. However, this is still tentative. I need to ask if we need to follow Beirut and Beirut would agree on this. Probably it's gonna be easier. Okay, so I'm gonna get back to you upon this. I'm gonna keep it on our weekly schedule. Yeah, I should put it in our last week for me to keep on. I don't want to lose it. So next time I see you where I'm writing my plan, I would see it again and probably give you an answer for this one. But I know for a fact that what you need to cover for the midterm is going to be lab 0, 1, 2, 3, and 4. This is final and not tentative. Okay, for Friday afternoon, if we're gonna do it Friday afternoon and nobody must follow our schedule, like we're alone, we pick the time you want. It could be evening, 6 p.m., 7 p.m., 8 p.m., anytime you want, okay? So even if it's March 27, I would target March 26, the day before, which is Friday afternoon. Okay, so how do you feel towards Friday afternoon? Evening, anything you want. Okay, so Friday afternoon, question mark. If nobody has to do the midterm at the same time as us, we can pick. Okay, what time do you finish cell lab, Yara? So we can easily sit in the evening, have something to drink, and do the midterm at 8 p.m. or 7:30. At 7:30 p.m., for example, that's only, I'm just asking you, probably it's not on a Friday. So you chill for Saturday, you're gonna be calm and chill and quiet and have a regular session. It is scheduled from 12 p.m. to 3 p.m., but we usually finish earlier. All right, so let's say this is a tentative timing for a Friday afternoon.
Fina 5.
Roy cannot do it between 6 and 7, and I think we need to allocate a minimum of 60 minutes.
So
Okay, let's see. 5 p.m. question mark, 4:30 p.m. question mark. Yeah, why not? I don't see why not. Somebody has a lab at 4. So the lab at 4, Genti will finish what time? I suppose it's not lab, it's a live session. At 7. Okay, so nothing between 4 and 7. Nothing between, undo. Nothing between 4 and 7. So nothing between 4 and 7, because I don't want to ask you again. That's why I'm writing it down. So 7:30 would sound okay, I suppose. Yes. All right. We still have a lot of time until then. Next week, we can refine it, like break it down into a more reasonable time. Meanwhile, I can ask to see if we need to follow by Beirut. Hopefully not. So everybody, it is a 60 minutes exam. Probably, I'm going to say between 40 minutes and 90 minutes, but it's more likely to be 60 minutes. Multiple choice, can we wait until next week so I can tell you? I'm not sure yet. Okay, but yes, please keep on asking me, and next week I will definitely tell you, and you have the right to know. Now the plan for today, let's discuss lab 2. It was a tough lab. I'm not in a hurry for you to submit it if you're not doing okay. Let's take time. Let me give you hints. Let's see what's your problem. Lab 3 is super easy. I was doing the presentation and I was like, wow, you're gonna be so happy, Ohm's law. This is baby physics. So let's take a while to discuss lab 2. I have this manual open for us. What's up with lab 2? Go ahead, ask me questions. By the way, did you manage to watch the offline section? It was like a 15-minute section that I had to do alone in your absence because of me getting disconnected. Okay, Yara, not a big deal. All right. Any question or not yet for lab 2?
Yes, doctor, I have one.
Yes, Genti, go ahead.
Regarding part C, okay, when they ask us to compare, we need to get the percentage error, يعني the relative error.
Yeah.
يعني بس to detect the accuracy لازم نعمل شيء تاني to detect the precision.
So percentage error, I call it percentage error, and actually percentage difference. Yes, if it's less than 5%, we say accurate. So less than 5%, we say accurate. For precision, the only way to discuss a precision of a value, which is the measured value, do you have the uncertainty on the measured value? It's the smallest subdivision since we're talking about a digital measuring tool. I don't have the values, but let's assume you have 495, I don't know, microfarad, okay, plus or minus 1 farad, microfarad. I would say to discuss precision, I would do the ratio uncertainty divided by the measured value. If the ratio is less than 2%, I would say it's precise. So here they're not discussing precision of one actual measurement or actual calculation, because for the calculated value you can find the error using the propagation of error. They simply want you to compare the measured and the calculated hopefully to discuss accuracy only. Okay? Did that?
Okay, G.
All right. Why did we use to consider less than 10% in 302? All right, Roy, let me explain a bit. 5% is an act something international, like universal. 5% to be considered accurate. Now, when we discuss our physics lab in our campus in Biblos, our physics Zachem engineering, we know for a fact that our equipment, the setups we have, are not super precise. Not all of them. In physics 302, mostly because you have friction, gravity, horizontal versus vertical, you know. So instructors usually say, do not expect to get something below 10%. I tell my students, do not expect to get something below 20%. I would say below 20%, I would say acceptable, but I never said accurate. All right, because when I get 18%, this is not accurate, but I know for a fact, even if you repeat the experiment 10 times, it's gonna be 18%, 17%, 15%. There's no way you get below 5%, unless in special cases, like you have really very effective something to measure, you will get below. But now in physics 306, especially with circuits, you will be surprised. The values are so close to the theoretical values because you don't have friction and sensors to deal with, you know? It's simply you're measuring current voltage and it's okay. You see, Roy? So basically, we never said below 10%. It's still below 5%, but we say below 10% is still acceptable because we have a lot of errors. By simply saying friction is neglected, this is big because friction is not neglected. So this is a big part of your 10%. Yes. Any other question? And the final question in the lab report, which C should we use? I don't know. Let's see. Cable, pick one cable. Okay, because I can see you have two cables, cable one, cable two, pick one. You have the diameter, the ratio is the same. The length, I don't know, it may be different. Just pick one and find K, the constant. I still have students who would want to pick two and do twice, but since they don't tell you inside the cable, pick one and it's okay. Did you try, Hussein, or not yet? All right, try and let me know how things would go. Somebody asked me before which one would be picked, so it's a common question. Yeah, what else? That's it for lab 2? But I have questions for you. Did you manage to plot and do the linear regression? Did you manage to find the error on the slope? Are you using the linist method or you're calculating the error on the slope using the equation? The slope, did you get it? Did you get a reasonable epsilon zero? Because always the students have difficulties getting epsilon zero close to the theoretical one. And usually they fall in the gap of different units, nanofarad or picofarad with the millimeter and then 1/millimeter, and it's gonna be a big mess. I know you guys, you are bright. You are one of my brightest groups, the brightest groups I have. But are you sure you have no issues with this one? Or probably you did not start yet. And when you compare, are you getting reasonable answer? And are you being able to list the sources of errors? I know in the video, in some of the videos, I don't remember, I'm talking a bit about what to expect and some sources of errors on my setup. I don't know if you can catch here and there from the video, or even if I don't say it while doing the actual thing, you can see it on the bench. Okay. Okay. Roy, if you ever start, and Yara as well, when you start, and if you ever have any question, please let me know. I'm willing to meet with each and every one of you for around 15 minutes each if you need, or simply answer your question on WhatsApp or on email, okay? All right. That's it for lab 2. In part B, the D is not given in the result. Oh, it's not? Okay. Really? Let me see. Lab 2 is, this is yours? My bad, I'm so sorry. You cannot work without D. D is not given. All right. You cannot work without D. Actually, you do not need D. Yes, you do not need D. I still remember actually D. It was 1 millimeter for one and 1.5 millimeter for the other one. Probably for the plastic smaller than the cardboard. But since C dielectric, actually K will be simply the ratio, you don't need D. Okay, so I'm gonna give you an approximate D just for you to have an idea. For the plastic plate, it was 1 millimeter using a regular ruler. And this one, it was 1.5 millimeter using a regular ruler. Okay. But please do not use this in your calculation, because if you do, probably epsilon 0 or k is gonna be a bit different. If you want and you give me time for me to check the calculation, I can give you a more precise D. But again, you don't need it, because the error you need to find on k will be simply the error from this guy and the error from this guy through propagation of error. And k is simply the ratio. So you do not need D in your calculation. However, you need D to understand the experiment. Yes. But I did the experiment, so I do remember 1 and 1.5. Okay. Yes. 0.1 divided by 2. Yes, if we're talking centimeters. Yes. So be careful, Genti. Always include a unit. All right. Any other question? That's it? All right. I can't wait for lab 3. It will be like a time for you to breathe. All right, let me just make sure nobody has any question. Okay, so back to our weekly plan. I love weekly plans. This is the first time I ever do them with physics lab. So done with this. Now we're gonna discuss this in one shot. Theory, experiment, and lab report. And this is what I have. I'm gonna move this to the side and this to the side. Okay, so I'm gonna follow this outline. I find it funny to put George's arm as a picture on the outline. This made me read a little bit about him. I was very touched with many items in his life, but I'm not gonna discuss it with you. Definitely, you can read it if you want to. We're gonna discuss Ohm's law in general. But by Ohm's law, I would want to get close to ohmic devices and not non-ohmic devices, and see how you think the approach would be. I'm going to show you the board and hopefully some measurements and how we do the resistance, I mean connections. So I'm going to show you the board and some connections, and then I'm going to discuss how we're going to do the measurements, because there's many ways to find the resistance using our sensors. I'm going to discuss the behavior of the light bulb again, because I'm going to discuss it a bit in here as well, and show you a video of the experiment. That's it. Quick, neat, easy. Ohm's law, you tell me, what do you know about Ohm's law? Anything you remember. Go ahead, shoot. U equals Ri. What is U? What is R? What is I? V equals Ri. What's V? What's R? What's U? And what does this mean? To state U equals Ri. All right, so U is the potential difference between the terminals of a load. Don't say tension, please. Say voltage or potential difference. R is the resistance. I is the intensity. Let's say current. Let's not say intensity, because some people would mix intensity and brightness. So let's discuss brightness of the bulb, because it could be intensity of light, you see. So brightness and current. I know you're probably translating from French. So voltage or potential difference, current, that's it. And R is the resistance. I'm talking about any load. And when I say any load, I'm discussing ohmic and non-ohmic devices. Can I say that this equation states that U, or potential difference, and I are proportional? So linear for ohmic, non-linear for non-ohmic. So Hussein, you're saying non-linear, and Yara is saying depending on R. Thank you so much. So if R is a constant, U will be proportional to I. If R is not a constant, U and I will not be proportional. However, you will still have U equals Ri with a variable R. So R will vary with time. So at this time, U equals Ri. At a different time, U equals Ri again with a different R. Okay? Yes, this is interesting to see because I know throughout your high school, you will always think of Ohm's law being proportional and only applicable for resistors. So this is something general. V is equal to I times R, definitely with the units that you already know. This is for ohmic devices. You will get I versus V or V versus I to be a straight line passing through the origin, and it's also applicable for negative currents and negative voltages because we're going there. And for the non-ohmic devices, like a regular bulb, you will have something like that, then something like that. And sometimes the behavior is not a function. So probably on the way back, you will end up with a different something. So I'm not gonna tell you now, probably show you later. By the way, I need somebody to help me. What does the slope represent in this case? No, not R, not R, not R. Actually, if you look very closely, the y-axis is the current and the x-axis is the voltage. So the slope would be 1 over r. Yeah, very simple question. Thank you, Reem. Okay, so very simple question, I know, and we're not gonna do slope anyway. All right, so Reem just came. She wrote, Yara is playing on the iPad. Yara is supposed to be studying. So she's simply telling me that my other one is not studying. How cute is this? All right, so now let's discuss again Ohm's law. We're gonna deal with resistors, and this is another resistor. Those are ohmic. You don't know yet how to read the color code, or probably you do. We're not gonna target it today, probably target it later on, just for the fun of it. You don't need to know this. And this is a regular bulb, okay? So we're gonna study both. This is the experimental board. This is how it looks like. You will see it in the video. This is the exact one that you will have. What do we have on it? This is a resistor. You see 10 ohms. This is another resistor, 33 ohms. And this is 100 ohms. It's not very visible. They are not connected. They are only connected from one side, okay, and not connected from the other side. So if you want them in parallel, you have simply to use a banana wire to connect them together to make them parallel, or simply leave them because you need each one alone, to be honest. And if you ever want them in series, they are already connected in series. You simply need to connect those to your power supply or anything you want, okay? What else do we have? This is a coil. I don't know if you remember what a coil is, bobine. And this is the inductance of it. It's 8.2 millihenry. Probably we're gonna work with this one. This is an iron core that you can remove from the slide here and put it inside the coil for you to increase the inductance. I think it's gonna increase to 15 millihenry. And here you have two capacitors. I don't know if you remember what capacitors are. 100 microfarad. Oh, we did capacitors in lab 2. My bad. 330 microfarads. Here you have a small resistance of, actually this is not so small, 1 kilo ohms. This is a LED, a light emitting diode. It's like a small bulb, not bulb, light emitting diode. This is the bulb I'm gonna work with. Apparently it takes up to 7.5 volts before it gets damaged. I'm gonna give it anyway something below 5 volts, so it's gonna be safe, or 2 volts. I can't remember. Probably in the video I'm gonna say it, but it doesn't matter. This is the connection. I'm gonna take my board, and this is the science workshop. Okay, the science workshop is connected to the computer, so I'm not using a voltmeter, neither an ammeter, although I could do that if I want, because the experiment is so simple, no need for a science workshop. But we have the software data studio that you guys know a lot because you've been using it in physics 302, except Lean, if I'm still remember right. The science workshop, you will actually use it in a very simple way. No need to use a sensor in a digital plug or an analog plug. You will simply use the power supply, and you can see a sinusoidal. Do you see the sinusoidal signal? Just a second, changing the pen. Okay, this is this sinusoidal signal. It means any signal. You will take a wire connected to the 10 ohms, take another wire, let me change the color just for me, and connect it to other terminal, just for you to send a current through the 10 ohm resistor. The output will send the current and will send a potential difference, to be honest, and will measure the resistance to it. And the software is gonna do U over I whenever it's needed, or it's gonna plot U versus I without any extra sensors. However, we have voltage sensors that we can use on channel A and channel B, but we're not gonna use them in this experiment. So the connection is so simple. This is another science workshop that we bought to the lab. It's new. If I'm not, no, this is not a picture from the lab. This is a picture from Google. But I'm going to use in the lab the same exact science workshop and the same exact board and the same exact wires. All right. So you see, you have the power supply in here. I'm going to simply connect power supply to, to the resistor, and that's it. Okay, what's the current direction? Very good question, Roy. I'm gonna use a sinusoidal variable current alternating because I want the current to vary from -5, let's say, to +5. And I don't care about the shape of the signal. It could be triangular or sinusoidal, as long as it's a variable. Remember, my point is to plot, and I never discussed the objectives of the lab yet. My point is to plot U versus I, or I versus U. So I need a variable range of I and a variable range of U for the software to take all these points and to do the best fit for me to be able to find the resistance. All right, and it's gonna be fast, and the frequency will be measured. So you would know, let's say 50 hertz, it's gonna be 50 repetitions per second, and it's gonna be so fast. I'm sorry for the mess. It's gonna be so fast, and you're gonna have a plot in a fraction of a second. So you're not doing any measurements, unfortunately or happily. The software is gonna give you the plot in a second. And I find this interesting. And then I'm gonna do the experiment again for resistance 1 and then resistance 2, and then connect them in series, repeat, correct them in parallel, repeat, and do the bulb. This is what will happen. So you will do resistance 10 ohms, and you will do resistance 33 ohms, which is the next one. This is 10, this is 33. And you're not, this is how the plot will look like. And you're not required to find the slope. I find this silly, but I think the reason why we don't want you to find the slope is only to practice more data analysis. So they will ask you to find the coordinates of this point, the coordinates of this point, and so on and so forth. And then find R for each, R for each, R for each, R for each. So if you want, you can open another slot for R, and then find the average, and then find the RMS. So I believe the point is only to practice RMS and not because we can simply find the slope and that's it. All right. We already have it. Yes, you're right. This is called the nominal value, or what's written on the board. And this is called the measured value. So now, and we discussed that in lab 2, you have the nominal value and the measured value, and both are not theoretical. All right, so nominal is what's written on the board, and usually this is not precise at all because, you know, if you go to the manufacturer who's doing the board, they do a lot of resistors in bulk, and they say all of these resistors are 10 ohms, and there's a big margin of error, you know. When you start doing measurements, your sensors, even if the sensors are not precise at all, they're gonna give you a precision which is much better than the nominal value. All right, so please keep this in mind because I know students are having sometimes difficulty on that level. Nominal value, you should know which one it is, and measured value. All right, so we're measuring the value 5 times, finding the average to increase precision, finding RMS. The nominal value is only written on the board. Is that it, Yara? Did I answer your question? All right, next we're gonna take the resistors in series. So I'm gonna connect and I'm gonna show you how in the video, probably do it with you here. So let's say this is your power supply in green. No, I need a reasonable color, red. Power supply. I'm gonna take a DC power supply or AC, doesn't matter. I'm gonna connect this to here and I'm gonna connect this to here. Now let's follow the flow of the current. The current is gonna flow in this direction. I hate the color, in this direction. It's gonna go through the resistor. They're connected. I just want you to understand they're connected. Do this. So now you see the resistors are in series. How many cables do you need? You need only 2 cables. One cable from the plus to this terminal, one cable from the minus to this terminal. Only 2 cables are enough for the series connection. Now parallel connection, I'm gonna undo all the connections. How do I do parallel connections? I'm gonna take this, plug it in here, take this, plug it in here. It's gonna go through the 10 ohms. Then I need one extra wire to connect those two together. Now you can see those two are in parallel already, and the power supply is connected to one side from here and to the other side from here. How many cables do I need? You tell me. Yes, 3. Excellent. One from the power supply, one from the other power supply, and one to connect them in parallel, okay? And you will be given 3 wires most because you don't need more in this experiment. So you connect them in series. The nominal value, how do you calculate the nominal value? Can you tell me? So they are connected in series. I know one of them is 10, the other one is 33. What would be the nominal value of our equivalent? You don't know? 43. How did you do that? We add them up. Yes, simply. So for a series connection, R equivalent is R1 plus R2. But since I'm using nominal value and nominal value, this is still called nominal value, or what should be written on it. I'm going to do the parallel connection. Who can tell me what is the value of the parallel connection, of the nominal value of R equivalent? Yes. And don't forget to do one over the answer, Karine. Anyone has a calculator? So I'm going to simply do 10 to the minus 1 plus, by the way, your calculators has an option -1 to the minus 1, and then do the whole thing to the minus 1. Yes, I will get something very close to 7 or 8 ohms. And this is still the nominal value. Now I'm going to click on record. You're going to get a graph, and you will take coordinates out of the graph. I don't know if you will measure the coordinates, or probably I do the measurements for you. You will find R for each, so you can open an extra slot for R, measure R for each, calculate R actually by doing V over I, and then do the average and the RMS. And these are the questions. Calculate the experimental value for each set, then find the average with the RMS, then compare the nominal to the average. They will be pretty close. And then comment on the possible sources of errors. They will ask you to comment on the sources of errors in this case and this case, and probably the same sources of errors, unless you see something extra between the two procedures. If you believe you have the same sources of errors, simply say same sources of errors in both cases. And if you see there's something extra you want to mention, because probably the procedure is a bit different, mention the something extra, okay? All right, I'm done with resistance measurement. Now I'm going to discuss the behavior of the bulb. I will plot V versus I, okay? And I think the axis is here, V. I'm using my trackpad by the way, so this is V versus I. And I'm going to reduce the frequency to a frequency that is less than 1 hertz. Less than 1 hertz means, yes, it means that the bulb is gonna go on and off so slowly, like on every 1 second and then off. If I go below 1 hertz, something like 0.3 hertz, and I think this is what I did in the video, it's gonna go on and off probably every 3 seconds. It's really slow. You can see with the naked eye the bulb going on and off. And if you look at the characteristic curve, you will see a weird behavior. It's not even a function. As the voltage increases, you have a behavior, decreases, you have a different behavior. But something creepy happens, and I don't know if it's visible. I did not take a screenshot, but I'll show you in the video. If you increase the frequency back to 50 hertz, okay, the bulb is gonna go on and off so fast that you will not be able to see it. 50 times per second, this is fast for your eye. So you're gonna see the bulb always shining, although it's going on and off 50 times per second. And the graph is gonna look linear. We say the behavior is a linear behavior, but it's still not an ohmic device. Okay? So, in other words, how this behavior, it depends on the frequency. Okay? I cannot tell you at the moment. What you need to do is you need to observe the graph very well in both cases. You also need to observe the brightness of the bulb. This is a screenshot from the video. And in the video, I will show you how the bulb is going on and off. Probably the behavior of the bulb and the behavior of the graph, you can find a link. If you go online and you Google how the frequency shows the behavior, ohmic, non-ohmic, I think you cannot find an answer. But probably you can read a bit about the behavior of a bulb as an ohmic device or not in general and try to link this case. So the case of varying the frequency may not be found in a textbook or online, but probably you can tell how the slope, which is the resistance, is affected, or how does it behave in the case of a bulb. All right? We can definitely discuss the answer before the midterm or later on, but I'm going to give you a week or a bit more for you to think about it. It's not tough, it's something common sense. All right, for the video, I included this slide just for me not to forget to show you the video. I'm gonna go fast forward. By the way, do you have any comments on the videos? Starting March 8th, I think I will be allowed to go to the campus again. And if you give me some hints, I can modify the videos a bit. What's wrong with the videos other than the fact that the camera is not a good camera? I would want to hear from you. What do you like and what you don't like? Probably I can include it. I would think, let me say it myself, I would want to describe verbally the experiment more, probably include more sources of errors, or probably give you more hints for the questions in the video. What else do you want me to include in the videos? Please speak up. Nothing? You're okay with the video that we have? Can you give me a hint or anything? Don't be silent, you freak me out. Am I disconnected?
No, Dr. Yusuf.
So I'm not talking alone. All right. If you think of anything, you will let me know. Okay. Please do that. I would love to change a bit the videos. What you said would be nice, but the videos are okay. Thank you, Yara, for your feedback. I really care about your feedback because you are the audience, nobody else. All right, now let me check those videos. Back to the first one. Here I'm explaining, showing you the board, explaining again what you have on the board. And I already did that in the presentation, showing you the back of the board, just to tell you how things are connected, showing you the cables, how many, discussing which resistors. I love this close-up. I usually use it. However, we can find the board on Google. And here now I'm gonna show you in a minute how to access Data Studio. And when I access Data Studio, I had old graphs, I had to delete them. Then I showed you the connections through my science workshop, showing you the cables, showing you the board, how I did the connection and how simple they were. Then I went to the thing, Data Studio. I clicked record, I got a straight line passing through the origin. Then I know this is not very visible, but I think it's my camera is not focusing well. It was close enough though. I'm sorry, I cannot increase the size. I can barely increase. It doesn't increase. So I'm gonna take the smart tool. Probably you know the smart tool. And I'm gonna take simply coordinates and give them to you. Then I'm gonna change, this is a series connection, showing you how they're already connected and how the whole thing is connected to your power supply. Yes. And you see the slope is different now. Look, the slope was less, now the slope is more. Probably because in series you do R1 plus R2, so the slope is R and the slope increased. But don't trust the pictures because probably the scale is different as well. All right, now I'm explaining probably how to do the parallel connection or not. Yeah, or no, showing you how I do the connection to the bulb. Same repetition. I go to change the frequency to something lower than 1 hertz, and I got this result. By the way, take this result to answer the question that says sketch V as a function of I for a light bulb at low frequency. You can take a screenshot of this or simply with a pencil repeat the same thing. Okay, and don't be scared to take screenshots from the video. Isn't it your experiment eventually? And from the presentation as well. Now I'm gonna change the frequency to 50 hertz and I'm gonna get something like that. Okay, let me show you how it's
And
done.
maybe take a picture of this one for you to keep. I will stop recording. I will go to my signal generator and I will put the frequency. By the way, the frequency was on 0.3 hertz. I will put it on 50 hertz, 50 hertz again. I will hide the signal generator and record it again. I will get this shape.
All right, I want you to see that the slope was less and then the slope increased. It is linear, yes, but there's a slight change in slope in the first few seconds. Probably this would help you understand what's happening. Okay, it is linear. And on other computers you don't see what happened the first few seconds, you simply see a straight line because the other ones would disappear. Okay, now here I'm showing you the behavior.
Focus on the bulb. The bulb is switched off. Yes. I will take my signal generator and make sure that the frequency is back to 0.3 hertz, back to when it gave me this weird shape. I will start recording. I want you to notice that the brightness of the bulb varies. It will go on and off, on and off. Slowly, the frequency is 0.3 hertz, so it does it 0.3 times per second, or maybe 3 times every, I don't know how many seconds, you know? It's 1/3.
Okay, so it's once every 3 seconds. I'm sorry for that.
So every 3 seconds, it does only one. It goes on only one time. So it's a very small frequency. That's why you see it very slowly going on and off. And at the same time, you get this weird shape that you saw on the voltage.
All right, now for 50 hertz, I really stress on this observation because this is the answer. This is the answer to the question in the lab report.
And I will start recording again. Notice that the brightness of the bulb is somehow constant. Some would say that it will go on and off so fast, frequency 50 hertz, meaning 50 times per second, that cannot be seen in the naked eye. I don't know on the video if you see any fluttering, any variation in the brightness, but using my naked eye, I see no variation in the brightness whatsoever. This could be somehow.
All right, so that's why I wanted you to see the graphs and take some time observing what's happening to the bulb because this would actually help you understand what's happening to the characteristic curve, okay? So that's it for the, I think we covered everything needed. So we discussed Ohm's law in general for both ohmic and non-ohmic, the board, how to do the measurements, the behavior of the bulb, a video of the experiment. I gave you some hints and you have some pieces, sections of the lab report in here to discuss. So if I go to our weekly plan, we're done with theory, with the experiment, and we discussed a bit the lab report. This lab is very easy. Just take it and consider it like a week off to breathe. Meanwhile, you will be receiving grades of lab 1 and probably lab 2 as well by the end of next week. All right, do you have any questions? Are you okay with the timing of the lab? Because I think the low number of participants could be the timing of the lab. All right. If you need any modifications, probably we can come up with something. Saturday, 11 a.m. sounds okay for me. Why not? And as you can see, our sessions are not being so long, probably due to the fact that you guys do not have any questions on the previous labs. In other sections, especially the students, the fresh graduates from high school, we're taking more than 30 minutes to discuss item one, not physics 306. I do understand this because they're fresh graduates and physics lab is new to them. In your case, it's easier. Data analysis is easier. So we're not, you see, check the time. It's still 11:47. So a 50 minutes live session in the morning with a coffee and a chit chat, I don't see it bad. It's unless you have a lot of other commitments and study. Probably some people are not morning people. Yeah. So if you need any change, let me know. So I'm gonna stop recording now. You can leave if you want. I'm gonna stay a bit.